cancer and tumors have an innate ability to do is to manipulate cells around it. It will actually recruit immune cells to the tumor microenvironment, the tumor immune microenvironment, and then it will create dysfunction within those recruited immune cells so that these immune cells are turned on other immune cells. So in a way, like the acidic environment or the hypoxic environment, here the immune system is used as a shield, but the tumor has the immune system doing its dirty work.
Welcome to Prescribed by Dr. Nathan Goodyear, where integrative oncology meets holistic healing. This podcast is your home for the latest in innovation, exploration, and elevation in all areas of integrative oncology, medicine, health, wellness, and beyond. Join me and a host of other innovators as we go from practicing to prescribing. Your daily dose of wellness begins now.
Metastasis. I'm talking about the cancer metastatic process. I love words, and the words that we use in cancer often are difficult to understand. So what I want to do in a series of ongoing posts is just dive into each word and actually describe what they are so that when you go into your doctor, whether it's yourself, a family, friend, loved one, and you're hearing these words, you're in the know, you're empowered to help make the right decision for yourself or with those that you're there with. So why is metastasis important? Well, the reason why it's important is because when you look at cancer metastasis, when it spreads, that's what that really means, is 90% of morbidity and mortality in cancer is when it spreads. Now, if there's one tumor spread site, then the survival drops drastically. But if there's multiple metastatic sites, then the survival drops even more precipitously. So though it is associated with the majority of morbidity and mortality, the number of metastatic sites are associated with worse and worse and worse outcomes. And in fact, when you look at, for example, cancer that is spread to the liver, basically that type of cancer, whether that's coming from the colon, whether it's coming from the pancreas or wherever, could be breast, you're going to see a significant drop in 5-year survival. And so knowing and understanding this word, I think really helps to empower you as a patient to make the right decision as it relates to cancer treatment, to hopefully prevent it, but also if it's present, to properly treat it. Now that word metastasis actually goes back to the 16th century and it means change of substance. So obviously that had nothing to do with cancer or medicine at all. But in late Latin, that word transitioned to mean transition, change, or migration. So you can see a little bit more link to cancer and the metastatic process. But it was in the 17th century in English where it became a shift of disease from one part of the body to another. So you can see how that relates to what we're talking about here with metastasis, but actually the word origin of it, going back to the 16th century, had nothing to do with medicine. Now, more and more we're beginning to understand this metastatic process, and I call it carcinogenesis to metastasis. Now, carcinogenesis is the genesis or the initiation of cancer. And metastasis, again, using the 17th century English, shifted disease from one part, the primary part, to another. So let's go through this process because we have a good understanding what it means. First, there's altered cellular metabolism. And clearly, most understand that in cancer, it has altered metabolism. It's very different than healthy cells. We have mitochondrial damage. So this altered metabolism and mitochondrial damage, they really go hand in hand. And this is actually even being borne out in the Hallmarks of Cancer Research published by Hanahan in 2000, 2011, 2022 with the most recent update here in 2026. And so we can't think of these in isolation, but we must think of these as basically cofactors or co-stimulators towards the process of cancer and then towards metastasis. But here we're talking about the development. Then we have altered genetic expression. This is epigenetics, above genetics. So we're not talking about germline mutations that you've inherited from mom or dad, or the mutations that the cancer has taken on, what are called somatic. But here we're talking about the altered genetic expression, the change in transcription, the change in translation above the DNA or the genome. Then we get disrupted cellular signaling. And a lot of what you see in cancer is just poor communication, whether it's the cancer creating poor communication or whether it's healthy cells around it not communicating effectively. And here the immune system is front and center in that process. Then we have the well-known growth aspect of cancer, proliferation. Because what is happening in cancer, whether that be through altered cellular metabolism, mitochondrial damage, the altered genetic expression, and the disrupted cellular signaling, which could include some of the somatic mutations, is you're going to get a pivot towards growth. And so these cells are going to grow unchecked, unregulated, because that is what cancer does, and it does it via some of those mechanisms that I just described there. But we're still at this point talking about the primary tumor. So amongst, again, this process, again, occurring at the same time, we can't look at it as a sequential process, is hypoxia. Hypoxia is a lack of oxygen. And of course, this triggers a lot of genetic expression changes, because hypoxia will trigger hypoxia-inducible factor 1 alpha, which will then trigger vascular endothelial growth factor, and this will then trigger growth factors, cytokine inflammatory signaling, all of this promoting growth, promoting immune changes that allow cancer to continue to grow and evade immune detection. So hypoxia is a key triggering factor in cancer initiation and cancer growth. I wouldn't put hypoxia there in the key aspect of how cancer spreads, but most people go, okay, cancer doesn't like oxygen. Otto Warburg actually described that, where we had aerobic glycolysis, which is the cancer using glucose as a source of energy, but doing so in a very inefficient manner, but to propagate speed and growth. And so And that type of glycolysis typically occurs in anaerobic states, but in cancer, what you've got is the presence of oxygen, but glycolysis. Here in hypoxia, we're just talking about the lack of oxygen, which is very common in the tumor microenvironment and in pockets within the tumor itself. So don't think that, well, tumor is hypoxic, meaning all of the components of the tumor are hypoxic, but you will see pockets of it where it is. Angiogenesis, as I just mentioned, hypoxia through hypoxia-inducible factor 1 alpha, through vascular endothelial growth factor stimulation, you'll get the production of angiogenesis and neoangiogenesis, which is this tortuous vessel blood supply growth that cancer so desperately needs to maintain and support its high growth potential. But you also need it to remove nutrients as well. Then we have lymphogenesis. Again, at this point, what we're really getting is the support, the initiation and support of a primary tumor growth. Lymphogenesis would be the next step. Then acidic tumor microenvironment. Again, I don't think we can connect this hypoxia and acidic tumor microenvironment as different. They're one and the same, because in a hypoxic environment, you're going to get typically an acidic tumor microenvironment. And that typically is going back to the altered cellular metabolism, where you get this aerobic glycolysis and you get this pivot away from glycolysis going to make 8 ATP to actually make 2. As a byproduct of that, the glycolytic pathway, instead of going down through other pathways to produce energy, such as a Krebs cycle and electron transport chain, then spits out lactic acid. The cells in that tumor microenvironment that are malignant then dump that lactic acid outside of the body. They pump it out, outside the body, outside of the tumor and the tumor microenvironment. And that creates, in essence, a acid shield. So when people talk about tumors and cancer being an acidic state, it's much more of a localized impact rather than a global impact, unless we're talking about very late in the process. So here, the altered cellular metabolism, the hypoxia, is also driving the acidic tumor microenvironment. Again, one begets the next, begets the next. It's a chain reaction, not necessarily a sequential process. But then we get into things where these steps start to really cause the primary tumor to not just grow, but to start to begin the shift to leave the primary tumor and go to distant metastatic sites. Tumor microenvironment immune recruitment. See, the tumor will actually recruit immune cells to its presence. And what cancer has and tumors have an innate ability to do is to manipulate cells around it. It will actually recruit immune cells to the tumor microenvironment, the tumor immune microenvironment, and then it will create dysfunction within those recruited immune cells so that these immune cells are turned on other immune cells. So in a way, like the acidic environment or the hypoxic environment, here the immune system is used as a shield, but the tumor has the immune system doing its dirty work. Another aspect of it is polarization, where macrophages, tumor-associated macrophages or tumor-associated neutrophils are recruited to the tumor immune microenvironment. And the hypoxia nature of the environment they encounter actually causes a shift from a M1 type anti-tumor macrophage type to an M2, which is a pro-tumor. So here, again, the environments that we've already described are also causing the recruitment, but also at the same time causing a shift in these immune cells to not just be dysfunctional, but also to change their actual function. And then we get tumor microenvironment immune suppression. So again, the tumor is recruiting immune cells to do its dirty work and then changing them to favor and support their survival and growth. But here it's something unique that really leads to a key, I say, rate-limiting step in how cancer leaves that primary tumor and spreads. And that is immune suppression. When the cancer, the tumor, uses the immune system, recruits them, it tends to recruit cells like myeloid-derived suppressing cells, like T-regulating cells. And these cells come into that environment, within the tumor microenvironment, and they create suppression to the immune system via cytokine signaling. So they might produce interleukin 10, which suppresses other immune cells that would be recruited in an anti-tumor way into that tumor immune microenvironment. So here, not only is the tumor recruiting immune cells, then creating dysfunction, then actually changing their function altogether in the dysfunction within the tumor microenvironment, but here it's actually recruiting immune cells that suppress immune function. And this immune suppression leads to immune evasion, which is a key rate-limiting step I would propose in how a primary tumor spreads to a metastatic tumor. And so this then local immune suppression leads to systemic immune suppression. And also understand, when circulating tumor cells are released from the primary tumor, they're not just released in solo. They're not released just by themselves. They are typically accompanied by other cells, such as platelets, cancer cell platelet aggregates. And what this allows the tumor cells that are being released to do is to have platelets surround it in this aggregation, and it protects it against the sheer forces of the blood against the tumor, as well as natural killer cells, which are circulating around looking for cells just like this. But then the systemic immune suppression, when these platelet cancer cell aggregate lands at a damaged endothelial cell in the vascularity, then that tumor cell starts to work to go inside, and that local immune suppression will enable it to do that. And again, all of this is immune escape, allowing tumor escape, again, from primary tumor to distant metastatic sites. But this cannot occur without immune involvement, particularly here immune suppression and immune evasion. But then we have intravasation, which is a process where I mentioned where the platelets bind to damaged cells, and what we'll then do is see these cancer cells intravasate into a new site where obviously the tumor has already prepared via immune modulation and other factors that soil, what's called the seed and soil theory, so that as this new seed arrives, it has soil that's already been prepared for this seed to actually implant and form a metastatic site. And this all is the process of dissemination. And what's crazy about this is when that primary cell, or that cell from the primary tumor that is, leaves and is surrounded by a cancer cell platelet aggregate, it carries that immune memory with it from the primary tumor, the immune memory of dysfunction, the immune memory of recruitment, of suppression, of pro-tumor, not anti-tumor. It carries that immune memory with it so that when it achieves the distant metastatic site, it carries that same immune recruitment, immune dysfunction, and immune suppression locally that then allows this distant metastatic site tumor to survive as it's planted in this soil at a distant site. And the next step is intravasation. This is when a cell is released from the primary tumor into the surrounding tissue and fluid compartments such as the blood vessels or even lymphatics. Now, it's important to understand these release of cells that you may have heard of as it relates to checking in the blood of circulating tumor cells. They're not in isolation because they have to survive. This is a very inefficient process. Typically, well under 0.1% of cells released from a primary tumor actually reach a distant metastatic site and survive and land and grow a secondary tumor there. So here in this intravasation process, they must be released with other cells. One such example is platelets. Platelets are cells that keep us from bleeding. They actually create clots to stop that bleeding process. Here, circulating tumor cells released are bound and covered by platelets, what are called cancer cell platelet aggregates. And what this does is it creates a protection, a force field, if you will, to protect against the sheer forces of the blood flow, in part, number one. Number two, the platelet in the cancer cell platelet aggregate protect the circulating tumor cells from the immune system itself, which is circulating around, such as natural killer cells, to find cells just like that and destroy them. So it creates a buffer, it creates a shield to protect it as it's released to circulate. Again, all of this happens in sequence as we're describing it, but understand once cancer invades, this process is all in motion, not sequential, but it's just all happening simultaneously at the same time. And then of course we have the process of dissemination. And this is a process by which intravasation then moves to the distant site where again with these platelets, which encounter damaged cell linings such as endothelium and blood vessels, they will actually land to be a part of that repair process, and they happen to be loading off cells there. And that would be extravasation, going from the fluid compartment into the distant tissue type. And so intravasation through dissemination to then extravasation. But understand, it doesn't just happen and that soil hasn't been prepared. There's actually a theory called the seed and soil theory, where the cancer, the tumor, has actually been using the immune system as well as other signaling factors. So when we're talking about altered cellular signaling, it's not just something that's happened locally, it's something that's happening systemically. And this is actually preparing that soil at a distant site to be prepared for when a seed comes along, a circulating tumor cell that survives the dissemination process to then land and survive and thrive. And so that process prepares the soil distantly, so when that intravasation, the dissemination, extravasation process has its basically full manifestation, it then reaches that distant site to actually then grow. But what's interesting about these tumor cells that are released, they don't just carry their own memory, they carry memory of the primary tumor. And so when we talked about tumor microenvironment immune recruitment, that's dysfunctional, that changes polarization, that's even immunosuppressive in that tumor immune microenvironment, allowing it to evade the immune system, that immune memory is carried with that circulating tumor cell. So wherever it lands through the intravasation, dissemination, extravasation process, wherever it lands, it carries that same immune escape that allowed it to escape from the beginning, that is the growth process, the initiation growth process, the carcinogenesis process, then the immune escape that allowed it to leave the primary tumor, and then allows it to escape the immune system at the distant metastatic site. All the immune memory. Then we have metastasis. That is the process of how a primary cell becomes a tumor through all of these steps, how it evades the immune system, spreads to other sites of the body, evades the immune system again, and then forms a distant or shift of disease from one area to another. And again, the impact here is significant in morbidity, mortality, and the number of distant metastatic sites play a role in survival as well. So I hope this review of the word metastasis has really helped you to better understand. We understand a lot about this process, but there's definitely a lot we don't know. But what we do know is the immune system plays a critical role in every aspect of this process. That's metastasis, the word, and the metastatic process. I hope this has been helpful for you. And if this has been helpful for you, please like, share, and subscribe this video. We really need your help to subscribe to this YouTube channel so that more people can be made aware of not only the words and what they mean, but how they can be empowered to control and target their tumor and heal at the same time.
Thanks for joining us on this episode of the Prescribe Podcast. All references supporting this episode can be found on the prescribe.com website. That's pre-scribe.com. To get your next dose of medical innovation, make sure you subscribe to Prescribe. We'll see you for your next refill.